Now we're going to start learning the types of connective tissues, how they're characterized, what their functions are, and how to recognize them. The first main group of connective tissues are called the loose connective tissues. Very few cells, not a lot of protein fibers, much more ground substance than in others, and the protein fibers are very loosely connected. The first of these is called areolar connective tissue, and we find it in the top layer of the dermis. So this is the epidermis, that's the surface of your skin. The papillary layer is the top layer of the dermis, and it's made of this areolar connective tissue. Areolar connective tissue is really commonly found between structures in the body, providing a little bit of cushioning. A lot of times it makes a layer around structures just to sort of gently hold things in place or in shape. The fibroblasts, remember those are the cells, are very clearly visible, very distinct. There's lots and lots of ground substance. That's the part that looks empty. The collagen fibers are distinct and by themselves. You can see single strands of collagen, but there aren't very many of them and they aren't well organized. And then we also see elastic fibers, which are these much narrower, darker fibers. And those are important because they stretch, and more importantly than that, they recoil back to their original shape. Okay, so you can always tell the difference between collagen and elastic fibers. Collagen is pinker, it's not as dark, it almost looks empty, it almost looks see-through a little bit. Elastic is much narrower, much darker. In function, collagen is strong and doesn't stretch. In the elastic fibers are very stretchy, and most importantly, they go back to their original shape. Okay, you don't believe me that that's the most important thing about elastic? Think about what happens if the elastic goes out of, say, your bathing suit. You put the bathing suit on, the elastic stretches, but then if it doesn't come back to its original shape, then your bathing suit falls off and now you're all embarrassed. See? It's more important that it comes back to its original shape. Now, the other kind of loose connective tissue is called adipose. Adipose connective tissue. Adipose is fat. Each cell is called an adipocyte. You remember cyte means cell, so these are just adipocyte, meaning the cells in adipose tissue. They're very large cells filled with a droplet of a lipid. When we look at them at low magnification, they look empty, and that's because when the tissue is sectioned to make the slide, the fat actually drains out. So what we see is the empty tissue. It's really important as a cushion against shocks and trauma. We're going to see it between organs in the body to help cushion them against each other. We're going to see it around the body, especially in places that often land on the ground like your butt. It's a really good insulation, so it helps to hold heat in the body. It's very, very efficient energy storage. And I don't know about the rest of you, but my adipocytes, they don't like to give up that energy. They're like, nope, I'm storing it, I'm keeping it, I'm never giving it up. And when they do give it up, then they get super cranky and I get all hungry and hangry. And then if I ever do lose some fat, then they just like make me super hungry, so I always gain it back again because these little assholes don't die. It takes them, well, they do eventually, but I don't know, it takes forever. They cannot divide, but you can always make more fat from your mesenchymal cells. If you need to store more energy, you can do that. All right, the other main group of connective tissues are the dense connective tissues. They have a lot more protein fibers, especially collagen fibers, and less ground substance, and fewer cells, not as distinct cells. So we have three types: dense regular connective tissue, dense irregular connective tissue, and elastic tissue. So dense regular connective tissue is found in tendons and ligaments, and the collagen fibers are packed very, very closely together, and they're all going in the same direction. So this means that dense regular connective tissue is really strong when pulled in one direction because these collagen fibers individually have a lot of strength lengthwise. But there's not much holding these fibers together sideways. So if they get pulled sideways, they don't have a lot of strength and they can break. And that's why the tendons and ligaments in your knee can break because they get twisted the wrong direction. So strong in one direction, not strong in the other direction. You can always tell dense regular connective tissue because the fibroblasts are just totally smushed between the collagen fibers. They just look like crushed. There are very few or often no blood vessels actually within the dense regular connective tissue, which is why it takes so long for ligaments and tendons to heal. They don't have good blood flow. Now, dense irregular connective tissue, again, has tons and tons of collagen fibers, but they're in clumps that are going every which way. So it looks much less organized. Now, this is the reticular layer of the dermis, which is the layer under the papillary layer. So the papillary layer is a thin layer of areolar connective tissue, and then under that is dense irregular connective tissue. The good thing about dense irregular connective tissue is that you can pull it in any direction and it's equally strong in any direction. It doesn't stretch very much. It has very few elastic fibers, but it is stronger in all directions, but it's not as strong as dense regular connective tissue in any one direction. So that's why it's good for things that get pulled in all directions, like your skin. It also, there's a layer of it around cartilage and bone, which we'll talk about when we do the skeletal system, and it forms a capsule around some of your internal organs. We'll talk about those as we talk about the organs themselves. Now, one other dense connective tissue is called elastic connective tissue. And I just have this diagram of it here. It's very distinct because it has so many elastic fibers in it. It always stains much darker. The fibroblasts are bigger and less well organized than they are in the other tissues. The collagen, there is collagen, it's packed close together, but it's interwoven with these dark elastic fibers. So that's elastic connective tissue. And we have one other fiber, which I want you to know, which is called reticular connective tissue. You remember reticular means related to a network. Reticulum is a network, or a lattice is another thing that a reticulum is. So reticular connective tissue has a lot of reticular protein fibers that make a lattice with big spaces between the fibers. Those spaces can then be filled with other kinds of tissue. In this case, this tissue is filled with bone marrow. And those are another kind of multipotent stem cell that makes blood cells. So we see reticular connective tissue in bone marrow and in the lymph nodes. So that's another kind of connective tissue. All right, so we've got reticular connective tissue, elastic connective tissue, lots of elastic, less collagen. Dense irregular connective tissue, lots of collagen in bundles going every direction. Dense regular connective tissue, fibers going in one direction, all collagen. And then we have adipose connective tissue, lots of big empty cells with their little nuclei pushed to the side. I always feel sorry for their nuclei. And then areolar connective tissue, very loosely organized, collagen and elastic going in every direction. So those are your primary connective tissues that you need to know at this point. We're not going to talk about bone and cartilage tissues until we do the skeletal system.